So in this video, we're going to have a look at the special case where we have what's called a repeated factor. So if I grab the question here, we can see x plus 1 is being squared. So x plus 1 is a repeated factor. And we're going to say that this can be written, as we've got down here, as some number over x plus 1, not squared, plus another number over x plus 1 squared. So this is the difference compared to before. And then for the other algebraic factor, 2x plus 1, we've also got some other number again. Okay? So I've done a couple of steps here just to keep this video a little bit shorter. So let's have a look at this one first of all. So where did all of this come from? Well, this is just my starting question on the left hand side, and again I've said that this is always going to be identical to, and what did I do with these numbers over here? Well, if I'm looking over here, I had a over x plus 1, so how could I get it to have the same denominator? Well, I'd have to multiply it by another x plus 1 and also a 2x plus 1 if I want it again to have the same denominator. Okay. For b as well, I've done the same thing for b. It had x plus 1 squared, which was already in here, so it was missing a 2x plus 1. So now it has a 2x plus 1 at the top there. Okay. And for c, already had 2x plus 1, so it was missing x plus 1 all squared, and now it's got that. Okay. From here, it's very, very, very similar. So you can compare coefficients if you like, or you can make simultaneous equations. Here I've picked x equals minus 1, which leads me to 2 on the left hand side. Remember, this is in the numerator only. The denominators are the same, so you can effectively ignore the denominators now. Okay. 2 is equal to minus b, so I put minus 2 is b. So I found this value here. If I put in x equals minus a half, this will ultimately give me the answer of c equals 3. Okay, I've skipped the working out on that one there. But b, I've shown you how to do that one. C, you can see what value you would need to use. So I can get b and c. It gets a bit more complicated though when you're looking at a. So the problem with a is that if you put x equals minus 1 in here, the whole thing will disappear. If you put x equals minus a half in here, again, the whole thing will disappear. So you can't solve this by carefully picking values. It's not possible. What you can do though is you can look at the x squared terms. So on the left hand side, I'm going to say that there are 11 x squareds. And on the right hand side, I suppose I could make this an identity if I wanted to. On the right hand side, there will be an x times a 2x. This creates 2x squared, doesn't it? And this 2x squared really is going to be 2ax squared. So that's why I've come up with 2a. Yeah, how many x squareds are there? On the left, there's 11. On the right, there's 2a. b over here, b doesn't actually create any x squared, so b is not in the equation. C, well, there'll be x squared here, and that's going to be it. So there will be c lots of x squared. So the 11 must be made of 2a on the left, 2a on the right, plus c. And if you remember, we already found out what c is. So we can actually write this as 11 equals 2a plus 3. So a has got to be 4. What can we do? Hopefully we've got enough time to fit this into the video, but we can put all of this into our final answer. So 4 minus 2 and 3, those were our values. And it goes over, let's just double check this a second. It goes over x plus 1, x plus 1 all squared, and 2x plus 1. And that's our final answer. Normally